Bismillahirrahmanirrahim. In our last experiments, we discussed about the biasing techniques of the bipolar junction transistors. In our today's experiment, we will discuss about the common emitter amplifier. When we use the bipolar junction transistor as an amplifier, so we have three possible configurations. We have the common emitter configuration, we have the common base configuration, and we have the common emitter configuration, common collector configuration. So today we will discuss about the common emitter amplifier or the common emitter configuration when we use transistor as an amplifier. So this is the circuit diagram of the common emitter amplifier. We have the transistor 292N3904. This is actually the model of the transistor, and we are using this transistor in a common emitter configuration. If we look at this circuit, the emitter of this transistor is actually common. We are providing the input signal to the base of the transistor, and we are taking the output from the collector of the transistor. If we look at this circuit, we have the coupling capacitors and we have the bypass capacitor. C1 and C3 are the coupling capacitors, whereas C2 is the bypass capacitor. Now what is the purpose of C1 and C3? Why do we call these capacitors as the coupling capacitors? Because the purpose of these capacitors is to block the DC signal and to pass through the AC signal. C1 and C3, these capacitors actually block the DC signal which is coming from the battery or some source, whereas it passes the AC signal. So through C1 we provide the AC signal to the base of the transistor and we take the output through this capacitor C3, whereas C2 is called the bypass capacitor because it actually bypasses the AC signal, or it actually bypasses the emitter current, hence increasing the gain of the transistor. So this C2 capacitor is actually the bypass capacitor because it bypasses the AC signal, or it bypasses the emitter current. So this is all about the circuit having the common emitter configuration. So we have a function generator and we have the oscilloscope. We can analyze the output by means of this oscilloscope, and an AC signal will be provided by means of this function generator. If we look at this circuit, we have the coupling capacitors, we have the bypass capacitor, we have the voltage divider circuit R1 and R2. They form a voltage divider circuit, and it is used for biasing of the transistor. Now to provide an AC signal and to observe the AC output, we need a function generator and we need an oscilloscope. So these instruments are actually taken from this side. If we look at the left side, so this is actually our different instruments. So from here we can take the function generator, oscilloscope, multimeters, and many more things. Now if we look at the oscilloscope, channel A, this is actually the channel A. Channel A is connected to the input, whereas the output is being observed by the channel B. The output is being observed at the channel B, whereas the channel A is connected to the input. If we look at this wire, I can change the color of this wire. I can change the color of this wire. so that the signal which we will observe on the oscilloscope can change. So here the output signal is blue and the input signal is red. Now if we look at the function generator, if we double click on the function generator, अगर हम function generator पे double click कर लें, so these are actually our parameters. जो हमारी frequency होगी that will be 1 kilohertz. यहाँ से हम frequency change भी कर सकते हैं. अगर हमें 2 kilohertz की frequency required है या 3 kilohertz की frequency required है, तो यहाँ से हम frequency change कर सकते हैं. But इसी experiment में जो हमारी frequency होगी that will be 1 kilohertz. इसी तरह जो amplitude है, amplitude ऑलरेडी मैंने यहाँ सेट किया हुआ है, that is 20 millivolts, because the transistor is actually a small signal amplifier. ये चूंकि small signals को amplify करता है, so I will give 20 millivolts peak to peak. इसी तरह अगर मतलब मैंने 50 millivolt करना है, या यहाँ से हम values भी चेंज कर सकते हैं, millivolt माइक्रो. So we have different values. तो हमारा जो input signal होगा that will be of 20 millivolts. और जो हम waveforms use कर रहे हैं, we can use different waveforms. We can use मतलब sine wave or square wave. So I'm using the sine wave. So these are actually the settings of the function generator. Now if we look at oscilloscope, so let me simulate this circuit. Actually we will look at the voltage gain of this circuit, we will look at the current gain of this circuit, and we will look at the power gain. So if we simulate this circuit, so these are actually the simulations. Now if we look at the waves, the output, so the blue wave is actually the output signal, whereas the red sine wave is the input signal. तो अगर आप इसी स्क्रीन को देख लें, so we are actually getting an inverted amplified output. We are actually getting an inverted amplified output. जो हमारा output है वो amplify हो रहा है, and that is actually being inverted because आप लोगों को पता है कि जब हम common emitter configuration use करते हैं, so उसमें 180 degree phase shift आता है. So that is actually an inverted amplified output. Now how can you people measure the voltage gain? So if we look at this cursor, by moving this cursor, we can easily measure the voltage gain. So by placing the first on the positive peak and the second channel on the negative peak, you people can easily measure the output voltage. So actually channel A is the input signal and channel B is the output signal. Channel A is the input signal and channel B is the आउटपुट सिग्नल. तो जो हमारा ट्रूथ है वो हम पॉजिटिव पीक पे रख लेंगे और जो हमारा पॉइंट है वो हम नेगेटिव पीक पे रख लेंगे. So we will get, if we look at here, T1 T2 minus T1, so 7.054 volt. This is actually our output voltage. Our input voltage is minus 39.288 millivolt, and we are actually getting the inverted signal. So approximately 40 millivolts peak to peak. चूंकि हमने 20 millivolts peak value अप्लाई की थी, तो चूंकि यहाँ पे peak value कंसिडर होती है, so our input signal is actually 40 millivolts peak to peak, and our output is 7.04 volts. So the output voltage divided by the input voltage, the output voltage divided by the input voltage will actually give us the voltage. Output voltage divided by the input voltage will give us the voltage gain. So this was all about the common emitter amplifier. Okay, जो हमारा सिग्नल होता है that is an inverted amplified signal, और यहाँ पे जो हमारा वोल्टेज गेन आता है वो काफी ज्यादा आता है. इसी तरह अगर हम सिमुलेशन को स्टॉप कर लें और हम रेजिस्टर को इंक्रीज कर लें या डिक्रीज कर लें, so what will be the effect on the voltage gain? So let's suppose I am decreasing the resistor. Let's suppose मैं इसको चेंज करता हूँ 3.9 किलो ओम. So when I change it to 3.9 kilo ohm, and let's simulate our circuit, and let's measure the output. So the output voltage got changed. So by changing the load resistor, the output voltage will be affected, and when the output voltage gets affected, our voltage gain will be affected. Now let's remove this load resistor and let's take the output from the capacitor directly. So let's simulate this circuit now and measure the output voltage. If we measure the output voltage now, by removing this resistor, the output voltage got increased. The output voltage got increased. So it means that जब हम resistors बढ़ाते हैं तो जो हमारा output voltage है वो reduce करेगा. जब output voltage reduce करेगा तो automatically voltage gain जो है वो reduce कर पाएगा. So this was all about the common emitter configuration when we use the transistor as an amplifier.